great. So, optics in Haskell. Today I would like to say a few words about great concept called optics. In particular, its implementation in Haskell. I would like to start with the idea of lens, how it's built, what was the motivation behind it, and then I would like to add Prism to our toolset and talk a little bit about great library called Lens. So a few words about myself. I'm Paweł Sączawa. You can contact me with my Twitter handle or by email. I work for this great company Scalac. So yeah, let's get started. What was the problem that we wanted to solve? Basically, we can have this nested data structure, which will be implemented in Haskell this way. Nothing complicated, just some nested products. As we can see, it's not working. The battery is dying. It's dying. As we can see, it's quite simple product data structure, but it's nested. We have this type foo that has nested bar has nested bus, and the bus is just this product. What's the problem? What if we have a value of type foo and we want to modify exactly, for example, field E in the lowest possible level of nesting? So this function would look like this. It's just for modifying field E having a value of type foo. As we can see, it doesn't look like a good code. It's error prone, it's boilerplate, and yeah, I don't think we can say anything good about this particular piece of code. And it just got worse when we want to do more complicated things. Example of that will be updating this field. Quite similar case, but we just want to update it. For example, add 3 exclamation marks at the end. So it just gets worse, and yeah, that's not the way to program to handle our code. So how can we deal with that? Some people a few years ago introduced this smart concept of lens, and yeah, let's work with a simple lens. We can define this simplest possible lens as this data structure that will have these setter functions called set that will allow us to set this field of type B in structure A, which will give us A back, and also this getter function that will extract this B value from A. Nothing complicated. So how would it look like in our case? Yes, so in Lens library in the environment, it's quite common case to rewrite these data structures and call these fields with underscore in the beginning. I will explain this why, but I think it's good to start with this and stick to the convention. That's basically how would our lenses look like for. Field B, that would be called our function that just extract from our foo data type field of type bar, and it's as we saw earlier, just field B. Quite simple pair of set and getters. The same for field C and field A. Nothing big, but it has one great trait that it composes, and it's quite crucial, like in general in functional programming. What can we do with that? So it's common to define this function, composing lenses. This example, we have 2 lenses and we want to compose them. Similar to function composition, this is how the body of this function looks like, nothing complicated. So, yeah, as I stated, it composes, so this lens for field E in all those nested levels looks like just that, and it allows us to set the field as well as get it from this multi-level data structure. And yeah, it's also, the usage is quite simple and straightforward. Just get the set function from our lens. We can set whatever we want and to some existing value. It's also simple for a case when you want just update the function, and nothing unexpected here. The code looks gets just simpler and more easier to maintain. Yeah, so this is how it looks to update the value info in some value. So lenses also have to comply to some laws. It's quite important. So they work well. First of them is you get back what you put in, nothing unusual. The second law is also straightforward. Putting back what you got doesn't change anything, and setting twice is the same as setting once. Nothing unexpected here as well. I'm not even sure if it's possible to write code that wouldn't comply to those laws in purely functional manner. Okay, so it was great idea, quite simple. We can compose this with our operator. We also can provide instance for category, so we could compose this with this dot from category type class, but in this case we would have to override the dot operator from prelude. So what can we do with that? Not everyone wants to get rid of function composition operator. Some smart guys have asked this question, and this guy van Laarhoven came with this idea, which he called CPS-based functional references. The idea is basically to represent our lens with a single function, which is great. This is how it looks like. We have to add this language pragma, so we could use here for this functor higher candidate types. Basically it means a lens that lets you set values and get values. It's just this function. Actually understanding the meaning might take a while. At least it has taken from me quite a lot of time. So maybe with example how the instances look like. It changes a little bit. So we just have to learn some pattern that we can use later for providing those lenses for these different fields. After a while, nothing complicated as well. What does it give to us? It's just a function, so we can compose them like normal functions. Yeah, this practically the same case as before. We are composing these complicated lens from the simple ones, just using simple function composition. And our operators for setting and updating changes a little bit, but it's written just once and that's all. And the usage here hasn't changed at all. In my opinion, great idea. That it's like functional programming, nothing unexpected. But here comes another problem. What if we have a polymorphism embedded in our data type? Let's modify our example that before mentioned field E has polymorphic type. Basically, it can hold in field E any kind of types. So if this type is used here, it also propagates to the surface. It complicates things a little bit, but also there is great idea to polymorphic lens representation, which gives us quite similar definition of a lens, but only difference is that these types are not the same, and here as well. Also, why it's important to have this built as just simple function. Creator of this basically stated, Edward Met, stated that it's not always easy to make people use your library if they don't always add new dependencies, like adding this new data type lens would complicate it a little bit, would add new dependency to the project. Not everyone wants to do that. This is just type definition, so it's just a function. So you can ask someone to just return function in some type. It's not that complicated. Yeah, what's the difference? It's example of our lens field B. It just changes and adds a little bit of types, but it's not complicated as well. It means like if we have this type foo with A, polymorphic type A, and we have inside this bar A, and we want to change bar to bar B, it will change the enclosing type to foo B. And it's quite similar. Actually, even this definition doesn't change at all. So just quick win for free, and it gives us a lot of power. And yeah, as all other lenses representation, it also composes, so great. So yeah, that's our definition. Simple example of that is so I provided here monomorphized types for this lens. So basically, if we have float string, and so this deeply nested value has type string, and we would like to change, for example, from maybe int. And yeah, so this means we will be changing this type from string to maybe int, and overall type will change from string to foo maybe int, and yeah, it's just making the types concrete and nothing unusual. This is how we deal with that. Okay, so there is also this lens library, which started with this concept of lenses. Most notable person that is active there is Edward Met. Yeah. If someone is interested in Haskell, probably he or she knows him. It basically covers the idea of lens that I presented. It also gives us a great tool of not dealing with boilerplate with lenses. Instead of providing all those instances, you can just write this template Haskell definition that will provide all those lenses for us. This is also why we choose to name our fields in records with underscores. That's how the templating is implemented in Lens library. Of course, not everyone wants to use template Haskell in their code. It's not really encouraged to do it. But the amount of boilerplate it's safe is tremendous, so maybe it's worth of doing an exception for that. Okay, so also another thing is that quite important in optics are prism. The basic idea with prism, basic difference between prisms and lenses is that lenses work with product types, so we always know that all those values are there. It's like a tuple, it's always there. And prism work with some types, so like either. So it takes sometimes left value, sometimes right, and that's the idea, the difference. So how the prism type looks in Haskell in Lens library, it's a little bit complicated. It's the same, pretty much the same idea of a function, but there is a little bit of tweak here that f is applicative functor, and it also and p has to be choice, and choice is choice profunctor. It just gets worse. It's more complicated, so I just put here so we could know that it's still just a function, but with a little bit more complicated types. Don't worry, I don't think that too many people understand this this definition, but the main idea for us, we can use it. So in my mind, the most notable operator for prism is this one, asking for a value. So basically we provide this value, and we provide prism here, and we get maybe a, because we can ask if this value of type either is a left or a right value. Of course, as you probably notice, it's getting here, and I will get back to it later, but let's imagine that it can be prism for our for the sake of argument. How we use it? So the simplest idea is having this either value, asking if is this left. Yes, it is, so it gives just with the value. What happens if it's right? It returns us nothing. What is great about this, of course, it composes. So when we have nested values, we can compose our prism, like in this case, we compose two left prism, and we ask this for a recompose time, and it works as expected. It has found this value, so it returns this in just. Yeah. So getting back to our example, right now I changed this field f to be either of string int or string. I provided these lenses for these data types with this template Haskell thing, and yeah, so having this example value, which may look like this. This is how we would work with this with lenses. So basically we take this full value, we apply this lens, which is composed from field B, field C, field E. That's the example we talked before, and we set new string value. As you probably have noticed, it's quite similar to any kind of object-oriented programming, Java or C or whatnot. At least it looks so. What's the idea with Prism? That's more the most surprising thing for me, and one of the best. So because these things are just functions, Prism composes with lenses, seemingly. So there's no problem composing two different things. As we can, here should be result of this computation, but something went wrong. The type of, we can ask for the type of this definition. So we compose those three lenses with this prism at the end, and it tells us that it's this function type that looks like this, with this constraint on f functor, and if you dig into lens library, you will notice that it just type definition for this traversal. What is traversal? It's another thing that is defined in lens library. So the team behind lens library has identified a lot of things that it allows you to compose your software from smaller pieces, like lens is always built from getter and setter, and so on. Yeah, so this forms a hierarchy that looks like this. We have our lens that we started with, and also we have Prism here. If we want to compose those two things, it turns out those composes, and they take the form of closest simple ancestor. So as we have noticed in our example, lens composed with Prism gives us traversal. Simple as that. Really powerful tool. Yeah, it resembles a little bit like hierarchy known from object-oriented programming. As we can see here, there are quite a lot of different concepts that I really encourage you to get to know this. Yeah, that's a really great library, a lot of great ideas. So basically that's all from me. Thank you for your time. Stolen meme from the internet. You're welcome, and yeah, that's all. Thank you.